Hello and welcome to our lesson on polynomial division and synthetic division. This is going to be from section 8.3 in our text. We have basically three concepts that we need to get through in this lesson: the remainder theorem, the factor theorem, and the synthetic division. So let's go ahead and get started. First, the remainder theorem says if a function is divided by a linear factor, x minus a, the remainder of that division will be the same as the function value f of a. Now that's actually kind of cool. It's basically saying, hey, there's a shortcut for knowing if the long division is going to work out and give you a zero remainder or not. The function value f of a will give you the remainder when you divide f of x by x minus a. Again, that's kind of a cool theorem there. And the next one is probably just as cool. The factor theorem says if the function value f of a is 0, then the linear polynomial x minus a will be a factor of f of x. So what that's saying is if you solve this for x and you plug it into the function, if it works out to be 0, then this is a factor of f of x. Again, kind of cool there. And then the synthetic division we're going to talk about in a minute is basically a shortcut for long division, provided that your divisor is a linear polynomial. For our first example, number 3 here, it says for the function g of x, use long division to determine whether each of the following is a factor. From the factor theorem, we know that if the remainder is 0, then the divisor is a factor. So we're going to use long division because it specifies long division. And let's go ahead and set that up real quick. Okay, so we have our long division set up. We've got the divisor and the dividend. Notice that when you write the dividend, every power of the variable must be represented. That means x to the 3, x to the 2, x to the 1, and then your constant. All of those terms have to be represented in order to do the long division. So let's get started. Long division. First things first, ask yourself, what would I multiply x by to make x to the third? And whatever that is, that's going to be the first term of your quotient. So that's going to be x squared, and then we need to distribute. X squared times x makes x to the third, and these guys should always match because you designed it that way. Next, x squared times negative 4 is negative 4x squared. Once you distribute, the next step says draw the line, change the sign, and then combine. X cubes are going to cancel. 4 minus 2 gives us a 2x squared, and the minus 11x comes down. Now you can also bring down the 12 if you want, but it's not necessary. And then we're going to rinse and repeat. So that means now you're going to ask yourself, what would I multiply x by now to make this guy? And that's going to be 2x. So the next term of our quotient is positive 2x, and then we need to distribute. So you can see there's a lot of repetition here in long division. Distributing 2x times x gives us 2x squared. 2x times negative 4 is negative 8x. Next, draw the line, change the sign, and then combine. Those are going to cancel. 8, 9, 10, 11. That's a negative 3x. And I believe this is going to be our last time through in the long division. Okay, so now we're going to ask ourselves, what would I multiply x by to make negative 3x? And that is negative 3. And then we're going to distribute. Negative 3 times x makes a negative 3x. Negative 3 times negative 4 makes a positive 12. Notice I forgot to bring my 12 down, so that's a plus 12 coming down. And remember, the next step says draw the line, change the sign, and then combine. Cancel. Hey, look at this. 12 minus 12, cancel. That leaves us a 0 remainder. So if we were labeling stuff, this is the quotient. Down here, we've got the remainder. And the answer to the actual question, it says use long division to determine whether each of the following is a factor. So this is a yes or no question. Yes, x minus 4 is a factor of this polynomial. But not only that, the quotient is the other factor. So if you were asked to factor this function, you could say, well, it's going to factor as x minus 4 times x squared plus 2x minus 3. Those would be the factors. And then if you need to factor it further, you could factor this trinomial. All I'm saying is if you get a 0 remainder, the divisor is going to be a factor. That's a yes. And then we need to do it again for part B. And so since we walked through it pretty slowly the first time, we're going to go a little bit faster this time, okay? What would I multiply x by to make x to the third? That's going to be x squared. And then we're going to distribute x squared times x to the third. X squared times negative 3 is a negative 3x squared. Draw the line, change the sign, and then combine. 3 minus 2 is 1, x squared minus 11x plus 12. I'm going to bring it all down this time. And then we're going to rinse and repeat. What would I multiply x by to make x squared? That would be positive x. And then we're going to distribute. X times x is x squared. X times negative 3 is a negative 3x. Draw the line, change the sign, and then combine. And that's going to be negative 8x plus 12 comes down. And then we're going to rinse and repeat one more time. What would I multiply x by to make negative 8x? And that would be minus 8. And then distribute. Negative 8 times x is a negative 8x. Negative 8 times negative 3, that's going to be a plus 24. And I already have a bad feeling about this. Draw the line, change the sign, and then combine. 12 minus 24 is a negative 12. That is not a 0 remainder. So that means that x minus 3 is not a factor. And so we would simply put no, that's not a factor. So do you understand the premise here? The fact that the remainder, whether it's 0 or not, is going to determine whether your divisor is a factor or not. Next, number 7. And the reason I wanted to throw this out here with the instructions is because sometimes the instructions can be really confusing with all the math notation. So it says in the following, a polynomial p of x, that's going to just be a function p of x, and a divisor. Now that's a key word. Divisor is d of x. That's this linear function. Are given. It says use long division. So we're going to be using long division again to find the quotient, and we're going to call that q of x. And the remainder, we're going to call that r of x. When p of x is divided by d of x. So we're basically going to set up this problem as a long division problem. And then when we get done, we're going to express the answer in this notation. And I'll try to make that clear when we're done. Okay, so let's set up our long division. So there's our long division set up. And I can't stress enough that when you're doing long division, every power of the variable must be represented even down to the constant. X to the 3, X to the 2, X to the 1, X to the none. And then we can crank out the long division. So what would I multiply X by to make X to the third? Well, that would be X squared. And then we need to distribute. X squared times X is X to the third. X squared times 9 is a plus 9X squared. Next, draw the line, change the sign, and then combine. Cancel. 6 minus 9 is negative 3x squared minus 25x plus 18. I'm bringing them both down. And then we're going to rinse and repeat. What can I multiply x by to make negative 3x squared? That is negative 3x. And then we're going to distribute. Negative 3x times x is a negative 3x squared. Negative 3x times 9 is a negative 27x. Draw the line, change the sign, and then combine. Cancel. 27 minus 25, that's going to be 2x plus 18. One more time. What can I multiply x by to make 2x? That is a positive 2. And then we're going to distribute. 2 times x makes a 2x. 2 times 9 is 18. Awesome. Draw the line, change the sign, and then combine. And we do get a 0 remainder. Now, does anybody remember what that means? When your remainder is 0, that means that x plus 9 is a factor of the dividend. Now, to express the solution the way they want it, it says in the form of d of x times q of x. So I've already got my d of x right here. That's going to be x plus 9, and I do need to put that in parentheses, times q of x. Now, q of x, remember, is the quotient, and that is the answer up top. So the q of x, the quotient is x squared minus 3x plus 2. And then it says plus r of x. Now, r of x is the remainder, but our remainder is 0. So we're simply going to say plus 0. If you want to express it the way they want it, you need to have the plus 0. Next example, number 11, we're going to look at synthetic division. And I do need to premise this by saying synthetic division only applies if your divisor is linear. You have to have a linear divisor to use synthetic division. Okay, so I'm going to lay out the steps for you. Step number 1, you need to take the divisor, set it equal to 0, and solve. And so that's going to give us x is negative 3. And then we're going to stick that number in a little box here. Next to that box, we're going to write out the coefficients of the dividend, making sure that every power of the variable is represented. So starting with x to the 4th, that coefficient is 2. And then the next would be x to the 3. And then next would be x to the 2, x squared. Notice there is no x squared in this dividend, so we're going to need to put a placeholder. And the reason we put 0 is because, well, there is none of those. 0 means there is no x squared. And then x to the 1 has a coefficient of 1, and you do need to have the constant represented. So if you're missing the constant, you would need to put a plus 0 out there for the constant. Then the next step in synthetic division is we're going to draw a line right down here, leaving enough room to write numbers above it. And that's the way you set up the synthetic division. Now, how do you actually crank out the synthetic division? Okay, there's steps involved here. But really, there's only two steps. And those two steps are multiply and add. Okay, but really the first step is you're going to take this first number, the 2, and you're going to bring it down below the line. Any number below the line is going to get multiplied by the box number. So then negative 3 times 2 is negative 6. The multiplication there goes above the line. Numbers that are above the line get added. 7 minus 6 is 1. Again, numbers below the line get multiplied. Negative 3 times 1 is negative 3. 0 minus 3 is negative 3. And so really it's just a bunch of multiplication and addition, honestly. Next, negative 3 times negative 3 is 9. 9 and 1 is 10. Negative 3 times 10 is negative 30. I'm going to draw a little line here. Negative 30 and negative 12 is negative 42. Now what this line does is it separates the quotient from the remainder. So if we were asked to write the quotient as a function, you would say q of x is, and then this 2 would be the coefficient of the first term of the quotient. Now the quotient is always going to be degree 1 less than the dividend. So the dividend had a degree of 4. So this 2 is going to be x to the third. Again, your quotient, the exponent is always going to be 1 less than your dividend. And then you just keep going. So that's 2x cubed. The 1 would be 1x squared minus 3x, and the 10 is the constant. There's the quotient in function notation. And if you were going to write the remainder as a function, it would simply be r of x is negative 42. Next, 25, it says use synthetic division to find the function values. Then check your work using a graphing calculator. We're not going to use a graphing calculator. We're going to use our favorite calculator, which is the Casio ClassWiz. Okay, any scientific or graphing calculator will work here. So the first problem, it says find f of negative 1. What we're going to do is we're going to put the negative 1 in the little box, and then we're going to write all of the coefficients of the function f of x, starting with the coefficient of x to the fourth, which is 1, x to the 3, x to the 2. X squared is missing. Remember, we need a placeholder. X to the 1 and the constant. And then the line, and then the synthetic division. So again, the way that works is the first number drops down, and then you multiply negative 1 times 1 and write it above the line. Numbers above the line get added. Numbers below the line get multiplied. Negative 1 times negative 4 is 4. 0 and 4 is 4. Negative 1 times 4 is negative 4. 2 minus 4 is negative 2. Negative 1 times negative 2 is 2. 8 and 2 is 10. Now don't forget this separator here that separates the quotient from the remainder. And if we go back up top to the remainder theorem, remember that says if the function is divided by x minus a, really that's what synthetic division is doing. It's doing the long division with a shortcut. It says the remainder will be the function value. So we can say f of negative 1 will be 10. The remainder is the function value. And then we're going to use our handy dandy calculator to check that. So if I plug in negative 1 in for every x, that'll be negative 1 to the fourth minus 3 times negative 1 to the third plus 2 times negative 1 plus 8 Bam, look at that. The function value is 10, same as the remainder. I don't know about you, but I think that's freaking sweet. All right, let's pull a Britney Spears. Oops, I did it again. F of 4. This time 4 goes in the box. Same coefficients. So that part's freaking easy. And then the synthetic division. So if you miss it the first time, here we go again. The 1 comes down. 4 times 1 is 4. 4 minus 3 is 1. 4 times 1 is 4. 0 and 4 is 4. 4 times 4 is 16. 16 and 2 is 18. 4 times 18 is 72. 72 and 8 is 80. So then we can say f of 4 will be 80. And again, we probably want to check that with the calculator. Now, if you have the class whiz, and remember we did the calculation a second ago for f of -1, if you cleared that and there's nothing there, you can actually hit the up arrow and edit the line that you typed in. May be easier than typing all that stuff in again. Okay, so we're actually just going to delete the -1 and change it to a 4. Okay, every -1 is going to delete and change to a 4 and gives us 80. So that's another advantage of the class whiz. It's easy to edit a line of code that you previously entered if you have to do repeated calculations like this. And one more function value to find, -5, using synthetic division and the remainder theorem. We've got our coefficients that are not going to change as long as we're working the same function. And then the 1 comes down. -5 times 1 is -5. And -3 is -8. 5 times 8 is 40. 40 and 0 is 40. -5 times 40. 4 times 5, that's -200. And 2 is -198. And then I'm going to grab my calculator for some help with that. -198 times -5. Whew, 990. That's going to go here. And 8 is 998. So, unless I screwed something up, f of -5 should be 998. And I sure am going to check that with the calculator just to make sure. And we're going to change every 4 to -5. Delete -5. Delete -5. Fingers crossed. Whoo, 998. Isn't that great? And that's how you do synthetic division to find a function value. But that also shows how you can use the calculator to get the function value too. But again, I think it's freaking cool that you can do synthetic division and the remainder is the function value. Math is awesome. Next, number 31, they want us to use synthetic division to determine whether the numbers are zeros of the polynomial function. And so for these values to be zeros, you need a zero remainder. That's basically what they're asking for. So we're going to set up our synthetic division first for the number 3, checking to see if -3 is a zero. We need the coefficients of the function, making sure that every power is represented. So there's x to the 3, x to the 2, x to the 1, and the constant, remember, absolutely necessary to have the constant. Draw our line, and then we're going to crank out the synthetic division. The 3 comes down. -3 times 3 is -9. 5 minus 9 is -4. Negative 4 times negative 3 is positive 12. 12 minus 6 is 6. Negative 3 times 6 is negative 18. Oh, snap, crackle, pop. 0 remainder. Now, when you get a 0 remainder, that means that negative 3 is going to be a 0 of the function. But what does that mean? Well, it means that if you graph f of x, it's going to cross the x-axis at negative 3. It's basically saying, hey, negative 3 is a solution to this equation, but it's also an x-intercept of the function. So what's the final answer there? Well, this is a yes or no question. So negative 3 is a 0? Yes, it is. And then we're going to check and see if positive 2 is a 0. Again, the coefficients are not going to change, so that part is super easy. And then to crank out the synthetic division, 3 comes down, 3 times 2 is 6. 6 and 5 is 11. And 22, 11 times 2, 22. 22 minus 6 is 16. 16 times 2, 32. 18 and 32 is 50, which is not 0. So this time, since our remainder is not 0, that means that 2 is not going to be a 0, which means if I graph this function, it should not cross the x-axis at 2. And I think I'm going to use Desmos to prove that. So what I've done is a little Desmos magic here. I put the function into Desmos, and then to get this nice, beautiful graph, I actually had to come up here to the wrench, and I had to adjust the x-axis and the y-axis boundaries a little bit. Notice that the x-axis goes from negative 5 to 5, but the y-axis goes from negative 32 to 37. So I did have to distort the axis to make this nice smooth curve. But the point here is that our math says negative 3 should be a 0, which corresponds to an x-intercept of the function, and 2 should not be a 0. And if you look at the graph, you can see that it does definitely cross at negative 3, and it does not cross at 2. Not only that, it shows that negative 3 is the only 0 of this function. Now, since this is a cubic, that means it will have 3 solutions. So if we were to solve this for x and find all the solutions, negative 3 would be one of them. The other 2 would be complex solutions. And we're going to do that concept one more time. Number 35. Here, they want me to check these complex solutions to see if they are zeros. And this is going to be fun and exciting. So first, we're going to check I and see if it is a 0 of g of x. So we need the coefficients, x to the 3, x to the 2, x to the 1, and the constant. Draw the line. Now, strap in. It's going to be a bumpy ride. 1 comes down. Remember, the number in the box gets multiplied by the number below the line. 1 times I is I. And then these two values get added. So the way we're going to write that is we're going to write that in the standard form of a complex number. Negative 4 plus I is, well, negative 4 plus I. And then that is going to get multiplied by I. And so we're going to come over here to the side, and we're going to show that multiplication. You understand? We're having to multiply this complex number times this complex number. And that is going to require the distributive property. Negative 4 times I, that's a negative 4I. I times I is I squared. remember from your complex numbers, I squared is -1. So we can substitute. We can have -4i minus 1. And then to put that in standard form, we need to switch those around. So that multiplication is going to result in -1 minus 4i. That goes above the line. And then these get added. So to add 4 to -1 plus 4i, since the -1 plus 4i is complex, you're simply going to add the real parts together. 4 minus 1 is 3, and the minus 4i comes down. And then we have to multiply again. 3 minus 4i is going to get multiplied by I. We're going to bring that over here to the side. I times 3 minus 4i, and then that's going to need to be distributed. I times 3, that's a 3i, minus 4i times I is I squared. Remember, I squared is -1, so that's the same as -4 times -1, which would make that plus 4, and again, we need to switch those to put that in standard form. And so that would go up here. 4 plus 3i. And then these get added. So again, since that's adding a real number to a complex number, you simply add the real parts. 4 minus 16 is minus 12. And the plus 3i comes down. Now that last piece there, all of this is the remainder, which that is not equal to 0. So that means that I is not a 0. One more time, we're going to try -2i and see if it is a 0 of g of x. And so again, the coefficients are easy. They're not going to change. And the 1 comes down. That's my favorite part. That's the easy step. And then multiply. 1 times anything is itself, so that's a -2i. And then to add -4 minus 2i, you're just going to write it as -4 minus 2i. And I can tell that I need to have a little more room here. So I'm going to scoot that over. You might need to adjust your numbers a bit as you work these if you see you need more room. Next step, we need to multiply -2i times this complex number. So we're going to show that down here, -2i times -4 minus 2i. That's going to need to distribute. Negative times a negative makes a positive 8i. Negative times a negative makes a positive 4. Now watch this. I times I gives me an I squared. And what is I squared? It's -1. -1 times 4 makes -4. And so the answer there is going to be -4 plus 8i in standard form. -4 plus 8i goes above the line, and then these get added. So remember, if you add a real number to a complex number, you simply add the real parts, which here, that's kind of nice because those are going to cancel and leave me just 8i, a monomial. Next, we need to multiply that times -2i. -2i times 8i. Well, -2 times 8 is a -16. I times I is I squared, which is -1. And that is multiplication, which makes 16. That's going to go above the line. And remember, this is our remainder, which is 0. Now, that's good news for us. That means that -2i is a 0 of this function. But I'm going to throw in a bonus for you. Anytime a complex solution turns out to be a 0, its conjugate will also be a 0. Now, what do I mean by conjugate? It's going to be the complex number with the opposite sign for I. So if I were to do long division with positive 2i, I would also get a 0 remainder. One more time, complex solutions occur in conjugate pairs. You may or may not need that at this point, but I'm giving it to you free at no additional cost. If negative 2i is a 0, positive 2i will also be a 0. And I'm going to crank that out just for fun, just so you know that I'm not making stuff up. So let's do this one more time with positive 2i. Again, the 1 comes down. 1 times anything is itself. Negative 4 plus 2i. Well, negative 4 plus 2i. Can't add those. Not like terms. And then this is going to get multiplied by 2i. 2i times negative 4 plus 2i is going to require the distributive property. Now, I think I would also like to throw in another bonus feature, and that is that the class whiz can actually do this complex multiplication for you if you want it to. What you need to do is go to the menu, and the first thing over is complex. We're going to hit equal to select that. You can tell you're in complex mode because there's a little I up here. And now anytime I hit the ENG button, I'm going to get an I. So I can say 2i times negative 4 plus 2i. And the Casio will actually do that multiplication for me. And then remember to add a real number to a complex number. You simply add the real parts. 4 and negative 4, well, those are going to cancel and leave me negative 8i. That would need to multiply by 2i. So 2i times negative 8i, which we've already done that over here. We're going to get negative 16i squared, but I squared is negative 1, and that gives me 16. And do you see we're also going to get a 0 remainder there. So all of that work, just so you know that complex zeros, complex solutions occur in conjugate pairs. And I think I'm going to end on that note, okay? So that's going to do it for this lesson. If you have any questions or comments about anything I've done so far, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.